Welcome back, everybody. So, this section is all about correlation, right? How two things relate to one another. We talked about what the definition of correlation. We talked about making a scatter plot and being able to do that on our graphing calculators. Then we introduced this thing called R. Remember that the difference between R and rho. R is the sample correlation. Rho is the population correlation, right? And we can say things about rho dependent upon our R value. Our restrictions for our R value closer to -1 is a negative correlation, stronger negative correlation. Closer to +1 is a stronger positive correlation. And we talked about finding R value using our calculators. And now we can do, we did that thing where we used that table 11 in your books, right, in Appendix B, to say whether a correlation is significant. A correlation is significant. It's dependent upon the alpha as well as your sample size. So like in this case, this was my sample size of 1, 2, 3, 4, 5. And it's only got two alphas. It's got 0.05 and 0.01. And we can say if that R value is above the level in the table, then it's significant. If it's not, then it's not. Okay. So what we can do next is use hypothesis testing for population correlation coefficient. Hypothesis testing for population correlation coefficient. Remember, population correlation coefficient is rho, right? Is rho. It is the not the R value, but the rho value. Okay. So we really have three types of hypothesis testing. We can say, is there a significant positive correlation? Is there a significant negative correlation? Or we can say, is there a significant correlation? If we don't want to just say positive or we don't want to just say negative, we can say, is there a significant correlation? Remember that if it's a significant correlation, that means that rho is going to be not zero, basically. Okay? Rho is not zero because as we get closer and closer to zero, that's weaker and weaker, right? So our null hypothesis is that rho is zero. This is for if there is just a significant correlation. Our alternative would then be that rho is not zero. Don't even do it. So they're delaying your picture.
Please go to the main gym to have your photo taken. Also, the career-based intervention program students, please go to the main gym now to have that photo taken. Thank you.
You're welcome. Okay, we're good now. So what is this saying? This is saying that there is, if rho is zero, that's saying that there is no significant correlation, right? If we can reject that null, right? If we can reject that null, we say that no, we reject the statement that there is no significant correlation, which means that there is a significant correlation. Do we know positive to negative? No. But all we're saying is that there is a significant correlation between the population correlation coefficient. Okay. So if rho is now less than or equal to zero, right, that would mean our alternative hypothesis would be greater than zero. So remember, that would say that there is a significant positive correlation. Okay. That would be like saying that there is a significant positive correlation. And again, the goal is to try to reject your null hypothesis. A successful outcome for your hypothesis testing, remember, is to reject the null. So if I can reject the statement that rho is less than or equal to zero, we can basically accept to be true that rho is greater than zero, so it's a significant positive correlation. It's something bigger than zero. And lastly, if rho, we make that greater than or equal to zero, that would return our alternative hypothesis into less than zero, which would mean that there is a significant negative correlation. Okay? There is a significant negative correlation. So we just have to decide, what do we want to show? Do we want to show that there is a correlation, some sort of correlation, whether it be positive or negative? Do we want to show that there is a significant positive correlation, or show that there is a significant negative correlation? And then we can write out our null and alternative hypothesis accordingly. These are always going to be zeros for these, right? Because you're just showing something about your R value. You're proving something about your R value. And at 0, there is a no correlation, a very, very weak correlation, if any. So what's our test statistic then? What do we compare against our rho? Well, what we do is take our t sample, a t-test. So we're using our t-tables because, again, this is a sample. Our t-test can be used to test whether the correlation between two variables is significant. So we're going to be using our t-table. The test statistic is R, and our standardized test statistic follows a t-distribution with, this is a change, n minus 2 degrees of freedom. N minus 2 degrees of freedom. Basically, if we have one variable, we're using n minus 1 degrees of freedom. If we're comparing two variables against each other, we use n minus 2 degrees of freedom. Still the same t-test though, right? T is equal to R, and we know R divided by sigma R. Now, sigma R, we're never really going to write it as sigma R. This is the formula that you should know. It's on your formula sheet, or you should be able to recognize on the formula sheet. You take your R value, which you're able to find using your sample data, your R value divided by the square root of 1 minus R squared over n minus 2. 1 minus R squared over n minus 2. This is basically your deviation away from your R squared, right? Because R squared is going to be a number less than 1, right? So it's always going to be 1 minus a number less than 1, your deviation away from 1, divided by your n minus 2 degrees of freedom. And then we square root that because that's what standard deviation is. We square root our variance there. So that's what we're going to be using to compare for our hypothesis testing. So let's use this data. Now, is this the same data that we had in our calculators? Please say yes. No. It's not. That's okay. Let's just input this stuff. 1, 3, 4, 5, 9, and 10. 9, 15, 17, 22, 30, and 35. Okay, so use the following data. Can we support a claim of a positive linear correlation? Now, think back, positive linear correlation. I need to use this middle one that we wrote down, right? I want to show that we're going to reject the null. A successful outcome is rejecting the null, therefore kind of saying, yes, there is a positive correlation. Accepting the alternative almost, right? So we can say that our null hypothesis is going to be our rho is less than or equal to 0. And our alternative hypothesis is rho is greater than 0, a significant positive relationship. Because we want to prove that this is true, right? So which makes sense that our claim that we have is in the alternative. If we want to show that something is true, if we want to support some claim, it wants to be in the alternative. Okay, so all we need for our test statistic is our R value and our N value. R and N, right? That's all we need. We know that we're going to use n minus 2 degrees of freedom with an alpha 0.05. So alpha 0.05 and an n minus 2 degrees of freedom. So how many degrees of freedom am I going to look up? 4. Degrees of freedom is 4. N is 1, 2, 3, 4, 5, 6. And we are going to calculate our R value now. I'm going to go into my calculator. I'm going to go back out to my home screen. Stat calc 4 for my linear regression. And I see my R value is 0.9938. It actually gives you your R squared value as well, but we can run that number. 0.9938. Oh, no. No.
Pardon the interruption. At this time, senior class teacher. Your
It started.
As a senior class picture right there.
You were so confident because they had delayed it.
I know, I was so sure. Now I have the egg on my face. Sign, sit down.
You tried.
I'm gonna pause this video. You guys are gonna get back and I'm gonna finish it.
No, 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 no,